There are changes on our planet that happen silently, deep beneath our feet, on a timescale where a human life is but the blink of an eye. We do not feel them, but our instruments do. And for the past few decades, those instruments have been sending back increasingly strange signals. The first sign, the North, is moving. The magnetic North Pole, the point to which every compass on Earth points as an unshakable truth, has left its longtime home in the Canadian Arctic and is on a great escape towards Siberia at an ever-accelerating speed. The second sign, our shield is weakening. The magnetic field, the invisible shell of energy that protects us from solar radiation, has lost nearly 10% of its strength in just the last 2 centuries. And the third sign, a crack is appearing, a giant anomaly in the South Atlantic region where the magnetic field is unusually weak, is growing larger and affecting the satellites that pass through it. Individually, each clue may not seem too alarming, but when pieced together, scientists around the world are seeing an incredible possibility. Our planet may be in the early stages of a grand and rare geological event, a magnetic pole reversal. Welcome back to Science for Sleep. If this journey into our planet's mysteries resonates with you, a gentle tap of the like and subscribe buttons helps our quiet corner of the universe reach more curious minds. We also love to know where in the world you are joining us from tonight. Feel free to leave a quiet greeting in the comments below. Tonight, we will not look at these changes with fear. Instead, we will be explorers, learning about one of the planet's most powerful and beautiful natural cycles. This is the story of Earth's beating heart, of its invisible shield, and of a future where our compasses might one day point south. To understand the strange restlessness of our planet's magnetic shield, we must first journey to its source, a place more remote and inaccessible than the farthest star, a place of unimaginable pressure and heat deep within the Earth itself. Let us begin a slow, downward journey, leaving the familiar surface behind. We pass through the thin crust, the solid ground we live on, and descend into the mantle, a vast layer of hot, silicate rock that flows with the patience of a geological glacier over millions of years. But our journey does not stop there. We continue deeper for nearly 3,000 kilometers until we reach the boundary of the Earth's core. Here, the world transforms. We enter the outer core, a vast, churning ocean not of water, but of liquid, metal, primarily iron and nickel, heated to a temperature hotter than the surface of the sun. The pressure is millions of times greater than at the surface, so immense that it keeps this superheated metal in a dense, liquid state. And it is here, in this violent, hidden ocean, that the planet's heart beats. This heart is the Earth's geodynamo, the engine that generates our magnetic field. The process is driven by 2 immense forces. First, as the Earth slowly cools from the inside out, the very center of the planet, the inner core, is solidifying. This process releases heat, which causes the liquid iron in the outer core to churn and roil in great slow-moving convection currents, like water boiling in a pot on a planetary scale. Hotter, less dense iron rises, cools, and then sinks again. Second, the Earth's constant rotation, the same force that gives us our day and night, stirs and twists these rising and falling currents of liquid metal. Because iron is a conductor, this complex, swirling motion of charged, molten metal generates powerful electrical currents. And as the laws of physics dictate, any electrical current generates a magnetic field. This is not a small field. It is a magnetic field of planetary proportions, a colossal dynamo that has been spinning for billions of years. This field extends far out into space, wrapping our world in an invisible, protective embrace. This is the source of the shield, the beating iron heart of our world. But this engine is not a perfect, steady machine. It is a chaotic, turbulent system, a stormy ocean of liquid metal. And sometimes, the flows within it become unstable, disrupting the simple, stable dipole field we are used to, causing the poles to wander and the shield's strength to fluctuate. The strange signals our instruments are detecting on the surface today are the faint echoes of a growing restlessness, a deep and powerful change happening now in the fiery heart of the planet. This immense, chaotic engine, churning deep within the Earth, generates something of profound elegance and vital importance: our planet's magnetic field. It is a force we cannot see or touch, an invisible presence that has shaped the destiny of our world in the most fundamental way. Imagine it as a giant bubble of energy, a vast and intricate shield surrounding our planet, extending for tens of thousands of kilometers out into space. This is the magnetosphere, and its primary purpose is to stand guard against a constant and deadly threat from our own star. The sun, while a source of life-giving light and warmth, also unleashes a relentless stream of charged particles known as the solar wind. This is a torrent of protons and electrons, traveling at hundreds of kilometers per second. A stellar breath that, if left unchecked, would be catastrophic for a planet like ours. It would strip away our atmosphere, molecule by molecule, over millions of years, boiling away our oceans and leaving the surface exposed to lethal cosmic radiation. We need only look to our neighbor, Mars, to see the consequences of a world that lost its magnetic shield. The red planet was once a warmer, wetter world, with a thicker atmosphere and perhaps even oceans. But as its smaller core cooled and solidified, its geodynamo shut down, its magnetic shield vanished, and over the ensuing eons, the solar wind scoured its atmosphere away, leaving behind the cold, thin, and barren environment we see today. Earth was spared this fate because of its restless iron heart. Our magnetic field acts as a guardian, a silent protector. As the solar wind approaches, it slams into our magnetosphere, and the vast majority of its deadly particles are deflected, flowing around the Earth like water around the bow of a ship. The shield holds strong, preserving the precious, thin layer of air and water that makes life possible. But this cosmic battle is not entirely invisible. We can see its beautiful aftermath in the night sky. In the polar regions, some particles from the solar wind are captured by the magnetic field lines and funneled down towards the atmosphere. As these high-energy particles collide with atoms of oxygen and nitrogen in the air, they excite them, causing them to glow. This is the origin of the aurora borealis and aurora australis, the northern and southern lights. They are a victory dance, a glowing, shimmering curtain of light that reminds us of the immense and silent battle being waged on our behalf, far above our heads. It is a testament to the power of the invisible shield that has allowed life to not only survive, but to thrive and evolve in all its complexity over billions of years. And so, this invisible shield, born from the planet's chaotic heart, has protected life for eons, a silent and steadfast guardian. But the engine that powers it is not a perfect, steady machine. It is a turbulent, fluid system, and as such, it is constantly changing. The most tangible evidence of this change, the first sign that our shield is in a state of restlessness, is the curious and accelerating journey of the magnetic North Pole. It is important to remember that the magnetic North Pole is not the same as the geographic North Pole. The geographic pole is a fixed point, the northern axis around which our planet spins. It is a true, unchanging north. The magnetic North Pole, however, is the point on the Earth's surface where the magnetic field lines point directly downwards. The spot your compass needle is trying to find. And this point is not fixed. It wanders. For centuries, since it was first formally located in the 1830s, it meandered slowly within the Canadian Arctic, a predictable and leisurely drift. Navigators and scientists could track its position and update their maps accordingly. But in the 1990s, something changed. Its slow drift became a sprint. Its speed increased dramatically, from less than 15 kilometers per year to over 55 kilometers per year. It broke free from its historical wandering grounds in Canada and began a determined march across the Arctic Ocean, heading directly for Siberia. This is not a subtle change. It is a significant and rapid acceleration in geological terms, forcing scientists to update the world magnetic model, the system that our modern navigation relies on, more frequently than ever before. This great escape is a direct, visible symptom of the shifting currents in the Earth's liquid outer core. Imagine the liquid iron ocean we visited earlier. The magnetic field is generated by great, swirling vortices within this ocean. But these vortices are not stable. They can shift, grow, shrink, and interact with each other. Scientists believe that there are currently two large patches of magnetic flux deep beneath the Earth's surface, one under Canada and one under Siberia. For a long time, the Canadian patch was stronger, holding the magnetic pole in place. But recently, the Siberian patch seems to be strengthening, and the flow of liquid iron in the core is changing, creating a kind of jet stream that is now pulling the pole away from Canada and dragging it across the top of the world. This is not just a scientific curiosity. It is a powerful indication that the balance of power deep within the Earth is changing, and the simple, tupled or dipole magnetic field we have relied on for millennia is becoming more complex and less stable. It is the most dramatic surface level evidence that the planet's internal dynamo is in a state of flux, a restless phase that may or may not be the prelude to a much larger change. The wandering of the magnetic North Pole is the most visible sign of the restlessness in our planet's core, but it is not the only one. While the pole makes its great escape across the Arctic, the shield it generates is itself showing signs of a deeper, more widespread change. The entire magnetic field is weakening. Using historical records from ship logs dating back centuries and direct satellite measurements from recent decades, scientists have calculated that the Earth's magnetic field has lost approximately 9 to 10% of its overall strength since the 19th century. This is a significant decline in a geologically short amount of time. The shield is growing thinner, its protective power diminishing, albeit very slowly. This weakening is not uniform across the globe. It is most pronounced in a vast and mysterious region known as the South Atlantic Anomaly, or SAA. Think of the magnetosphere as a great, invisible energy shell around the Earth. The SAA is a large and growing dent, a profound dip in this shield that stretches from the coast of Chile across to the southern tip of Africa. In this region, the magnetic field is so unusually weak that the inner Van Allen radiation belt, a zone of energetic charged particles trapped by the magnetic field, dips closer to the planet's surface than anywhere else. This is not a theoretical concern. The South Atlantic anomaly has real-world consequences for our technological civilization. Satellites and spacecraft passing through this region are exposed to a much higher level of energetic particle radiation. This radiation can disrupt their electronics, cause computer glitches, and damage sensitive components. The Hubble Space Telescope, for example, does not take observations when it passes through the SAA to protect its instruments. Astronauts on the International Space Station have reported seeing strange flashes of light when they travel through the anomaly, a result of high-energy cosmic rays striking their retinas. And this weak spot is not static. Recent data shows that it is deepening and expanding westward. Furthermore, it appears to be splitting into two distinct lobes, a sign of the growing complexity and instability of the field being generated in the core below. The combination of a rapidly wandering pole and a large, expanding weak spot in the shield suggests that the simple, stable dipole, the familiar field with one north and one south poles, losing its dominance. The forces in the Earth's core that generate the magnetic field are becoming more chaotic, allowing for more complex, multipolar structures to emerge and challenge the main field. The fading of our planetary shield is another powerful clue that our world may be in a state of transition, a long and slow journey towards a new magnetic configuration. The wandering of the magnetic North Pole is the most visible sign of the restlessness in our planet's core, but it is not the only one, nor is it the most profound. While the pole makes its great escape across the Arctic, the shield it generates is itself showing signs of a deeper, more fundamental change. The entire magnetic field is weakening. Our understanding of this process began in the 1830s, when the German mathematician Carl Friedrich Gauss conducted the first truly global survey of the Earth's magnetic field, creating a baseline against which all future changes could be measured. Today, a constellation of sophisticated satellites, like the European Space Agency's Swarm mission, continuously map the field with incredible precision, and their data is unambiguous. Over the last 2 centuries, the planet's magnetic field has lost approximately 9 to 10% of its overall strength. While this may sound slow on a geological timescale, it is a furious pace of decay, suggesting that the geodynamo in the Earth's core is undergoing a significant transition. This weakening is not happening uniformly across the globe. It is most pronounced and most alarming in a vast and mysterious region known as the South Atlantic anomaly. If you imagine the magnetosphere as a great, invisible energy shell protecting the Earth, the SAA is a massive and growing dent in this armor, a profound dip that stretches from the coast of Chile across to the southern tip of Africa. In this region, the magnetic field is so unusually weak that the inner Van Allen radiation belt, a dangerous zone of energetic charged particles normally held far from the planet, dips down to just a few hundred kilometers above the surface. This is not merely a theoretical concern. The South Atlantic anomaly has real-world consequences for our technological civilization. Satellites and spacecraft passing through this region are bombarded with a much higher level of proton radiation. This radiation can disrupt their delicate electronics, cause their onboard computers to glitch, and permanently damage sensitive components. To protect its instruments, the Hubble Space Telescope powers down its main sensors and does not take observations when its orbit carries it through the SAA. Astronauts on the International Space Station have reported a strange and unsettling phenomenon. Even with their eyes closed, when passing through the anomaly, they sometimes see spontaneous, star-like flashes of light. These are not dreams or illusions. They are the physical impact of high-energy cosmic rays passing directly through their optic nerves or visual cortex. A direct, personal reminder of the invisible radiation that the shield normally stops. Scientists believe the cause of this weak spot lies deep within the Earth, on the boundary of the liquid outer core itself. They suspect there is a large patch of reversed flux on the core's surface, a region where the magnetic field is oriented in the opposite direction to the main field above it, effectively cancelling it out and creating a profound weakness. And this weak spot is not static. Recent data shows that the anomaly is deepening. Its area of lowest intensity is expanding westward at a rate of about 20 kilometers per year, and it appears to be splitting into two distinct lobes, or cells, of weakness. This suggests that the underlying chaotic motion in the core is becoming more complex, and that the simple, stable dipole, the familiar field with one north and one south poles, losing its dominance. The combination of a rapidly wandering pole and a large, deepening weak spot in the shield paints a clear picture. They are two symptoms of the same underlying process: the slow, magnificent, and chaotic reorganization of the planet's iron heart. The signs of a weakening and wandering field today are clear, but they beg a crucial question. Is this behavior a new and unique planetary illness, a sign that our shield is failing for the first time? Or is it part of an ancient, recurring cycle, a natural rhythm of the Earth's deep interior? To find the answer, we must learn to read the planet's oldest library, a library written not in books, but in stone. The science of reading this library is called paleomagnetism, and its story is a remarkable tale of scientific discovery. The key lies in volcanic rock. When lava erupts onto the surface, it is a molten liquid at thousands of degrees. Within this liquid rock are tiny, microscopic crystals of iron-bearing minerals, such as magnetite. As long as the rock is molten, these tiny crystals are free to move, and like trillions of microscopic compass needles, they align themselves perfectly with the direction and polarity of the Earth's magnetic field at that moment. But as the lava cools and solidifies into hard basalt rock, these tiny mineral compasses are frozen in place. Their magnetic orientation becomes a permanent snapshot, a fossilized record of the Earth's magnetic field, locked into the stone for millions of years. In the mid-20th century, geologists began studying these fossil compasses in ancient lava flows from around the world. What they found was a profound puzzle. While some layers of rock showed a magnetic orientation similar to today's, with the minerals pointing north, other layers, often directly below or above, showed the exact opposite. The minerals in these layers pointed south. It was as if, at some point in the past, the entire magnetic field had completely flipped. The most stunning confirmation of this came from the ocean floor. At the mid-Atlantic ridge, a great volcanic seam running down the center of the ocean, new crust is constantly being created as magma wells up from the mantle. As this new seafloor forms and spreads outwards from the ridge, it records the Earth's magnetic polarity at the time of its creation. When scientists towed magnetometers across the ocean floor in the 1950s and 60s, they discovered a breathtaking pattern. They saw symmetrical stripes of normal and reversed polarity on either side of the ridge, a perfect magnetic barcode stretching for thousands of kilometers. This was the undeniable proof. The Earth's magnetic field had not just weakened or wandered in the past. It had completely flipped over and over again, hundreds of times throughout geological history. by dating the volcanic rock layers on land. And on the seafloor, scientists have now created a detailed timeline of these reversals. We know the last full reversal, the Brunhest-Matuyama reversal, happened around 780,000 years ago. The strange signals of our modern era off the wandering pole, the fading shield, were no longer a unique mystery. They were a familiar echo, a known pattern. The message in the stone was clear. The Earth has done this before, and it is preparing to do it again. The restless heart of the planet is following an ancient, cyclical rhythm, and we are now, for the first time in human history, able to read the notes. The message recorded in ancient stone is clear. A reversal is a natural part of our planet's life cycle. But what does that process actually look like? How does a planet's magnetic field, a structure of immense scale and power, manage to completely flip itself upside down? The process, based on scientific simulations of the Earth's geodynamo, is not a simple or instantaneous switch. It is a slow, complex, and chaotic transition, a period of profound instability that can last for several thousand years. The first stage is the one we are beginning to witness now, the weakening of the main dipole field. The familiar and relatively simple field, with one clear north and one clear south pole, begins to lose its dominance. The churning currents in the liquid outer core that normally sustained this simple structure become more turbulent and disorganized. As the main dipole field fades, the second stage begins, a period of multipolar chaos. The magnetic field does not disappear entirely. Instead, it fractures into a weaker, more complex, and messy configuration. Multiple, smaller north and south poles can form simultaneously at various locations across the globe. During this time, a compass would become utterly useless. Its needle might spin aimlessly, or it might point towards a local magnetic pole in Brazil one day, and another in Indonesia the next. The clear, guiding line of a global north would be gone, replaced by a tangled web of weaker, shifting fields. This chaotic phase is the heart of the reversal. The planet's internal dynamo is no longer maintaining a stable, organized structure. It is in a state of flux, a transitional period where the old order has collapsed and a new one has not yet been born. This period of instability could last for the entire duration of the reversal, perhaps for 4,000 to 5,000 years. And finally, after this long period of chaos, the third stage begins, the re-establishment of order. The turbulent flows within the Earth's core begin to organize themselves once more. The smaller, multiple poles wane and disappear, and a single, strong dipole field emerges and grows in strength again. The planet once more has a stable, protective shield with a clear north and south pole. But now, the polarity is reversed. The new magnetic North Pole will establish itself over the geographic South Pole, and the magnetic South Pole will be found over the geographic North. A compass needle that once pointed towards the Arctic would now point steadfastly towards Antarctica. The great reversal would be complete. A new, stable, magnetic era would have begun, an era that would itself last for hundreds of thousands of years before the restless heart of the planet begins. The ancient cycle all over again. The prospect of the Earth's magnetic field collapsing into a chaotic, multipolar state may sound alarming, a time of instability and vulnerability. But this geological upheaval would produce a side effect of the most profound and ethereal beauty. It would set the stage for a light show of planetary proportions, a sky of light. As we have learned, The auroras are born from the interaction between the solar wind and our magnetosphere, a battle that funnels charged particles towards the poles, where they excite atmospheric gases into glowing. In our stable, modern world, this breathtaking spectacle is a privilege reserved for those who live in the high latitudes, a reward for enduring the long, dark polar winters. But during the chaotic phase of a magnetic reversal, this would all change. With the main dipole field gone, and multiple, weaker magnetic poles scattered across the globe, the solar wind would no longer be neatly funneled to the Arctic and Antarctic. Instead, charged particles would be able to dip into the upper atmosphere at many different latitudes, guided by the tangled, shifting web of the weaker magnetic fields. The result would be that the aurora, in all its glory, would no longer be a polar phenomenon. It could be seen everywhere. Imagine a night sky over the Sahara Desert, not just filled with stars, but with shimmering, silent curtains of green and pink light dancing above the dunes. Picture the skies above the Amazon rainforest, the dense canopy illuminated from above by vast, pulsating ribbons of light. Think of a quiet night over the Pacific Ocean, its dark waters reflecting a celestial ballet of shimmering, shifting colors that stretches from horizon to horizon. For the thousands of years that the reversal process lasts, the night would be transformed. It would be a world without a true dark night, a world perpetually bathed in a soft, otherworldly glow. The lights would not be the same every night. Some nights they might be faint, a gentle, ghostly shimmer. On others, following a solar storm, they could be breathtakingly intense, a vibrant, multicolored dome of light covering the entire sky. The familiar constellations would be seen through a translucent, moving veil of light, a celestial canvas of constant, gentle motion. This would be a sight of unimaginable beauty, a reminder that even in a time of great planetary change and chaos, nature can produce moments of the most profound and serene wonder. It would be a sky that no human in our recorded history has ever had the privilege to witness. A world painted nightly with global auroras is a beautiful, romantic thought. But living under a weakened and chaotic magnetic shield would present real and significant challenges to our modern, technology-dependent civilization. It is important to approach these challenges not with alarm, but with a calm, scientific understanding. First, and most importantly, there is no scientific evidence to suggest that past magnetic field reversals have caused mass extinctions. The fossil record shows no correlation between the timing of reversals and major extinction events. Life on Earth has survived hundreds of these flips. The core danger is not biological, but technological. Our entire global infrastructure, from communication to navigation to electrical power, has been built during a period of a relatively strong and stable magnetic field. A prolonged period of weakness would be a new kind of test. The greatest vulnerability lies with our satellite network. With the shield weakened, satellites in orbit would be exposed to a much higher flux of high-energy solar particles and cosmic rays. This could lead to more frequent electronic failures, data corruption, and a shortened lifespan for critical communication, weather, and GPS satellites. Our interconnected world relies on this orbital infrastructure, and protecting it would become a significant engineering challenge. On the ground, the primary risk comes from extreme solar storms or coronal mass ejections. In our current world, our strong magnetic shield deflects the vast majority of these storms. But under a weakened shield, a powerful storm could induce immense electrical currents in our long-distance power lines and pipelines. This could overload electrical grids, causing widespread and potentially long-lasting blackouts. It is a known vulnerability, but one that would be greatly amplified during a reversal. Furthermore, air travel, particularly on long-haul routes that pass over the polar regions, would face increased radiation risks, requiring flight paths to be altered and crews to be monitored more closely. The challenge of a pole reversal is therefore a practical one. It is a test of our technological resilience and our ability to adapt our infrastructure to a changing planetary environment. It is not an apocalyptic event that threatens human existence itself, but a slow, multi-generational engineering problem that we would need to solve together. After the long, chaotic twilight of the reversal, a period that could last for the lifetime of 100 human generations, a new order would begin to emerge from the planet's core. The turbulent, multipolar fields that had created the global auroras would start to coalesce and simplify. The flows in the liquid outer core would find a new, stable pattern. Out of this chaos, a single, strong dipole field would once again grow and assert its dominance, wrapping the planet in a renewed and powerful magnetic shield. The Earth would be stable again. The auroras would retreat to their rightful homes. At the poles, and the skies for most of the world would return to their familiar, dark, star-filled state. Life, which has endured hundreds of these events throughout its long history, would adapt. Migratory animals, after a long period of confusion, would recalibrate their internal compasses to the new, stable field. Future generations of birds, turtles, and whales would navigate with the same certainty as their distant ancestors, simply orienting themselves to a new magnetic landscape. For humanity, the end of the reversal would mean a return to technological stability. Our satellites would be safer, our power grids more secure. But one fundamental thing about our world would have changed forever. The new magnetic North Pole would now be situated over the geographic South Pole in Antarctica, and the new magnetic South Pole would be found over the geographic North Pole in the Arctic. A compass needle, which, for all of human history, had pointed us north, would now point steadfastly south. Our maps would have to be redrawn. Our very language of direction and exploration would have to be relearned. The sun would still rise in the east and set in the west, but the fundamental magnetic signpost of our world would be inverted. This would be the dawn of a new south, a new magnetic era for the planet, a quiet and profound testament to the Earth's power to completely reinvent one of its most fundamental systems. And so, a new magnetic age begins, and the world finds a new equilibrium. But this stability, like all things in the universe, is temporary. For hundreds of thousands of years, the planet will have a new and reliable magnetic field. But deep in the core, the chaotic dance of liquid iron continues. A relentless and turbulent ocean, and slowly, imperceptibly, the seeds of the next reversal will begin to be sown. It is tempting to view this great cycle of reversal as a flaw, a moment of dangerous weakness in our planet's design. But perhaps a better way to see it is not as a flaw, but as a feature. It is not a sign of sickness, but a sign that the planet is profoundly and powerfully alive. The pole reversal is the great, slow beat of the Earth's heart. It is the deep, rhythmic pulse of the geodynamo, a cycle of collapse and renewal that has been happening since the world was young. It is a necessary process, a way for the planet's internal engine to reorganize itself, to release built-up complexities, and to maintain its long-term stability and strength. In a way, our own bodies follow a similar, albeit much faster, rhythm. Every day we engage with the world. We build, we think, we connect, we maintain the stable order of our conscious mind. And at the end of each day, we must enter our own small state of quiet chaos and renewal. We must sleep. Sleep is a time when our ordered, conscious self gives way, allowing the deep, restorative processes of the brain to take over, to clear out the day's metabolic waste, to consolidate memories, and to repair and reset itself for the day to come. Just as the Earth's magnetic field must periodically collapse to be reborn stronger, we too must let go of the day's stability and drift into the quiet, restorative darkness of sleep. There is nothing to fear from the deep, slow rhythms of our planet. They are a sign of a living world, a testament to its enduring power. And now, it is time to honor your own, much smaller, but no less vital, cycle of rest. It is time to let the shield of your own consciousness weaken for a while, to let go of control, and to trust in the deep, restorative processes that await you. Let the planet's slow, ancient heartbeat be a lullaby for your own. Sleep well.